So continuing with this, if I do y2 minus y1, so that's 40 minus 55.
Minus 15.
So that's minus 15. And then 15 minus 40.
Minus 25.
So what can you tell me about the first difference? Is it constant?
No.
So since it's not constant, then I can right away say that this is not linear. Okay? So this is not linear because first difference is not constant. So whenever you see a table of value, in order for you to know if it's linear or not, you're gonna have to find your first difference. So we're gonna do the same thing with the second table of values. Again, we're gonna take a quick look at the x values and make sure that the x values are going up by the same amount. Because if they're not going up by the same amount, then we can't do this. Okay? So it's going up by 5, 0, 5, 10, 15. So that's good. To do the first difference, again, I have to do y2 minus y1. So 40 minus 0, that is 40. 80 minus 40, that is 40. 120 minus 80, that's also 40. So what do you notice here? That the first difference is constant. That means I can say that this is a linear function. Because first difference is constant. Are we okay with this?
Yeah, can you scroll up just really fast, just like
You want to see what?
Yeah.
So this is the case when I have a table of values. Now we're going to look at graphs. Okay? So to identify if it's a linear function, if it's a straight line, we say it's a linear function. It's as easy as that. We don't have to even think about it. We are going to have to look at the trend. How does it look? The first one is linear because it's a straight line. Okay? So look at the first graph here. It's the depreciation value of a printer. So when you buy a printer, every year it's going to go down by the same amount, by the same value. This is what the graph says, right? We see that this is a straight line, so we can say right away this is a linear function. Because it's a straight line. What can you tell me about the second graph, which is the surface area of a cube? Huh? Not quadratic, it's an explode. Well, it could be half quadratic. Yeah, but this is not straight line. So we can say that it's not linear. And we see that there is a curve in that graph, so it's not a linear function. Now we're going to look at the equation. What can you tell me about the first equation? It is a linear function, and how do we know that? Degree 1. say degree 1, if you look at the x value, right? If you look at the x value, it has no exponent. And if it has no exponent, that means there is an invisible 1 on top of it. Okay? That's why it's called degree 1. 1 in the math. If I look at the second equation, y equals x squared plus 5, it's a degree of 2. So is it linear? It is not linear. What can we say about this? It's quadratic, right? Because it's a degree 2. So this is not linear. It's quadratic. I'm just going to write quadratic here. And we're going to say that because we know that because it's degree 2. So if you look right here, right, that's a degree 2. Are you guys okay to identify these? Are you guys okay to identify these by looking at the table of value, by looking at the equation, and by looking at the graph? All right. So, when I'm looking at a linear graph, I'm going to have to look at two things, if they're available. So the two things are the following. So if I have the graph right here, I look at the y-intercept, so where the graph intersects the y-axis, okay? And I also look at the steepness of the line, okay? Because remember that in the equation of the line, I have two things. I have mx plus b. I have the slope, and I have the y-intercept, okay? So when I'm analyzing a graph, a linear graph, I'm gonna have to look at these two things, the y-intercept and the slope. So the vertical intercept, which is the y-intercept. So the vertical intercept represents the value of the dependent variable.